These questions are from the PP1 to PP5 questions that are in the shared folder on Edmodo. Okay, so we're given the following circles, and it says write down the radius of C1 and the coordinates of A and the centre of C1. Okay, so the first one's really easy. What will go inside this bracket to make that 0? So that would be 1 minus 3. And then the radius is the square root of whatever that answer is there. So square root of 25 is 5. For B, it's not quite as simple because you have to put it in that form first. So to put that into the form, I'm going to get x minus, and then you half the x coordinate. So half that becomes 8, and you get rid of the square and you square it there. So you're completing the square on this bit. But then you always take away whatever that is squared. So take away 64. And then it's going to be plus brackets y minus, no, y plus, and then half of 4 would be 2 squared, but then you always take away whatever that is squared. So take away 4. And then we've still got a plus 67 on the end there. And then you rearrange to get it in the same form as it was in the line above. So we're going to get x minus 8 squared plus y plus 2 squared equals, and I'm just putting it into my calculator. Well, I can see that's going to be minus 68 there, plus 67 would be minus 1. Take it over would be 1. So the centre for B is going to be 8, because that's the value that makes that bracket 0. This value would be minus 2, and then the radius would be the square root of 1, which is also 1. Okay? So that's that one done and that one done. Show that C1 and C2 do not intersect. So how would you do that? The best way to do it is probably to start and draw a picture. Now, whatever you do, don't actually draw the axes, but just picture them in your mind. So I'm picturing my axes being roughly here. Okay? 1 minus 3 would be across 1 down to minus 3 there. So that would be A 1 minus 3. And then its radius is 5. Okay, then it says 8 minus 2, so I'm going all the way across to 8 and then up to minus 2, so that would be roughly about here. And then before I draw the circle, I know it's only a radius 1, so I guess it's small, because it says they do not intersect. When I draw it, I'm going to make sure they don't actually intersect, but I'm doing that through reading the question. Okay then, so if I go and work out the distance between these two centres, I'm just using Pythag to do that. You can use your formula if you want. Then I know this radius here, we'll call that R2. For the second circle, we'll call that R1. Then if I work out the distance, this distance must be greater than the sum of the radiuses. So I've gone from 1 to 8, that's a distance of 7 in the horizontal. And then I've gone from minus 3 up to 2, so that's a distance of 1 in the vertical. So this length, so I'm going to say distance between centres is equal to the square root of 7 squared plus 1 squared, which is root 50, which is 7 point blah 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 blah. Okay? Now, if I do radius 1 plus radius 2, I get 5 plus 1, which is 6. I'm going to say as 6 is less than root 50, or I could have said the 7, blah blah blah. It follows that C1 and C2 do not intersect. Okay, sorry, you can see what I'm writing, do not intersect. Okay. Finally then, part D. It says the point P41 lies on C. So 41 must be way up here, round about here. That's P lying on C1. Okay, now I'm told that the line BP is the tangent to C1 at P. So if I draw a line going through P, it also goes through B there. They're saying that that is a tangent. Okay, now if it's a tangent, a radius meets a tangent at 90 degrees. So I'm going and drawing that in too. So to show that that is a tangent, what I'm going to do is work out the gradient from P to A, which is the gradient of the radius. I'm then going to work out the gradient from P to B, and that will be the gradient of the tangent, and then I'm assuming those two values will times together to be minus 1. Okay, so part D, I say gradient of radius would be the difference in y values, so 1 minus minus 3 over 4 minus 1, which is 4 over 3. I'm then going to say gradient, and I'm going to say BP for now because I don't know for certain that it is the tangent. So gradient of BP would be the difference in y, so 1 minus minus 2 over 4 minus 8. That comes to 3 over minus 4. I'd say as 4 over 3 times by minus 3/4. I've just changed my minus just being at the top, which is fine. You can leave it on the bottom, doesn't matter. Equals minus 1. Therefore, BP is tangent at P because its gradient is minus 1. Okay. Question number 2. I've rewritten this just so you can see it a little bit more clearly. By here. It says determine the coordinates of A and the radius of C. That's pretty straightforward. It says show that the point B, 7 minus 5, lies inside C, and then it says C, find the radius of the larger circle with the centre B that can be drawn inside C. Write down the equation of this largest circle. Okay, that's probably going to be quite hard, that bit. I think I misread it the first time I did this. Okay then, so part A. So part A, the centre, I'm going to change that to x minus 3 squared minus 9 plus y plus 2 squared minus 4 minus 23 equals 0. And then I'm going to change that to x minus 3 squared plus y plus 2 squared. And then minus 9 minus 4 is minus 13, minus 23 is minus 36. Take that over, becomes 36. So the centre of A is going to be 3 minus 2, and its radius will be the square root of 36, which is 6. Okay, so that's part A done. Okay, part B says show that the point B, 7 minus 5, lies within C. Okay then, so to do that, I am going to say B, 7 minus 5, so x equals 7, y equals minus 5. I'm going to sub it into this side here of what I've already done. If it is equal to 36, that shows it is a point on the line. If it is less than 36, it's inside the circle. And if it's greater than 36, it's outside the circle. So I'm going to say 7 minus 3 squared plus, not y is minus 5, y minus 5 plus 2 squared. That becomes 4 squared plus minus 3 squared, which becomes 16 plus 9, which is 25. And then I'll state by here, 25 is less than 36, therefore lies inside of what they call it, inside C. Okay. Right, part C. It's time to do a drawing now. I may have to skip this and come back to it when I've read it through really thoroughly. I misread it the first time I did it. It says find the radius of the largest circle with centre B, which can be drawn inside C. Write down the equation of this larger circle. Okay, it may not be as hard as I thought. So centre A, first of all, that is what we found up the top here. It's 3 minus 2. So 3 minus 2 there. Its radius was 6, so I'm going to draw a circle there around it, which is 6. Okay, now I've just found this point B, 7 minus 5. So 7 minus 5 must be here. And I'll draw it inside purely because I know that it lies within the side C from what I found before. So that is A, and this is B. That's 7 minus 5. Okay. Now, in terms of what I just worked out, I worked out that this distance here, before I square root it, that was 25. Okay, so that means the distance between these two is a distance, so that's 25 squared effectively. So this distance would be 5 centimetres or 5 units, whatever you want to call it. Now that means if the whole radius, that's going to be 11, isn't it, by there? Okay. So in terms of the equation of the circle I can have, I want to go for that 11. I want to draw that around it. Okay, so my equation is going to be x minus 7, because what value would make that 0 was 7. That's 7 there. 7 minus 7 is 0 squared. Plus, now this is going to be opposite way around this time because it's minus 5. Y plus 5 squared. And because I've already gone 25, 25 plus 11 makes it 36. So I believe that would be equal to 11 there. And that's what it asked me. It said find the radius of the largest circle of B. So I'm going to say therefore radius would equal root 11. Write down the equation of this large circle, which I've done. There's my equation there. Okay, and then finally question 3. So you can see it. I've made those signs stand out a bit more than they currently did. Okay then, it says, oh, this isn't anything to do with it, so I'll just put a line through that. It says find the coordinates of C, pretty straightforward. Show that 9, 8 lies outside the circle. Okay, pretty similar to the last one. And then it says the line PT touches the circle at T. Find tan CPT. Okay, now that sounds hard, and it usually will be, okay? So first of all, for part A, I'm going to say that is x minus 3 squared plus y plus 4 squared. And then I'm going to say, I'm going to show you my shorthand way of doing this. I'm going to take that minus 11 over to get plus 11. And instead of take away 9 and taking away 16 there, I'll just add them straight to this side. So add 9 and then add 16. So that's going to give me x minus 3 squared and then y plus 4 squared is equal to 36. Okay, so the centre coordinates would be, 3 minus 4, and the radius would equal the square root of 36, which is 6. So there's part A done. Part B. Okay, so we've got this point 9, 8, which is point P. I need to prove that lies outside the circle. So if it lies outside the circle, I'll sub in x equals 9, y equals 8 into this line here. Okay, but I'm going to ignore the equals 36. If it equals 36, it touches the circle. If it is less than 36, it lies within inside the circle. And if it's greater than 36, it will be outside the circle. Okay, so that's going to give me, it's going to give me 9 minus 3 squared plus 8 plus 4 squared. So that's going to be 36 plus 12 squared, which is going to be 144, which is equal to 180. So I'll say greater than 36, therefore P lies outside C. Okay? Right then, part C, as always, draw a picture, try and get your head around it. So centre 3 minus 4, here. 3 minus 4, roughly there. Radius 6, there. The point P lies outside the circle, so 9, 8 is going to be miles away up here and way up here. Okay, so that's C, and that's P of 9, 8. Okay, now the wording here, it says PT touches the circle. So if it touches the circle, that means it's making a tangent to the circle. So I'm going to draw a line there. Now, I could be wrong, it may not be there, but I'm just going to treat it as there. It could be that it's a tangent by here, it could be that it's a tangent all the way over here, or here, one of them. Okay. I know that a radius meets a tangent at 90 degrees. So I'm going to go and add that in, and I know the radius is 6. I then need to go and work out either one of these sides here. Okay? Now, I can't go and work this one out because I don't know what the value of t is. I don't want to try and work it out. I don't know how to work it out. Okay? However, I can find this because I know what the centre C's coordinates are, and I know what these points are here. So I'm going to do that by using Pythag. I'm going to do the square root of the difference in x squared, so 9 take away 6 squared, plus the difference in y squared, so 8 take away minus 4 squared, which would give me the square root of, I've actually answered that one, haven't I? 9 minus 3 is 6, that should be 9 minus 3, so that's 36 plus 144. Hang on, have I done that right? 8 minus 1, got a different answer here from before. Yeah, that's not minus 4, is it? Right, I've made a mistake up here. Okay, so because that value there, y, is 4, no, that is 4. Where have I gone wrong? 3 minus 4, I'm happy with that. Right, no, maybe I haven't made any mistakes at all. Maybe I'm just thinking I have. Okay, right, I'm going to stick with this then. Is equal to the root of 180. Okay then, so root of 180 I'm just going to leave as root of 180. Now, because in the question it said find, if I show you back at the top here, it says find tan of CPT. C to P to T is this angle here, so I'll just call that theta for now, just to make it easier. If I'm to find tan of it, this is the opposite and this is the adjacent. I've just gone and found the hypotenuse. I can't go and find tan if I know the hypotenuse, so I need to find the adjacent. I'll do that through doing Pythag. So to find the adjacent, it would be root of 180 squared, take away root of 6, it was not root of 6, take away that squared equals the adjacent squared. So I'm then going to solve that, so that's going to be 180 take away 36, which comes to 144 is equal to the adjacent squared, so is equal to the adj square root that. So 12 is equal to the adjacent. Okay, and then to work this out now, SOHCAHTOA, I need to do opposite divided by adjacent. So the tan of theta, which is this tan of the angle they've asked me to find, is equal to the opposite, 6, divided by the adjacent, which is 12. So tan of theta is equal to 1/2.